Hi. So today we are going to talk about a very interesting topic. The topic is basically how do you plan ahead your performance testing strategy during holiday seasons, or when do you expect a huge amount of load in your API or on your e-commerce application. So how can you plan ahead in such situations? So specifically, I'm not going to discuss the general guidelines about it. What I'm going to do is I'm going to share one case study that we achieved at SDFC Life. So myself, Monish Correia, I'm working as a QA lead at SDFC Life. And basically, I'm going to share the tips or the steps that we followed on improving the API testing strategy at SDFC Life. So the case study was like this. HDFC Life was in the process of merging or acquiring Exide Life Insurance. And as part of that, we anticipated that one of the API, which is called as DD API, deduplication API, we anticipated that this particular API will have huge number of requests per second, and we wanted to test the performance of the same. Now, as an organization, we were using JMeter tool for carrying out the performance testing. But over the period of time, we found out that JMeter consumes lots of memory when it compares to per user execution, per virtual user execution. So our VP of engineering reached out to me and he told me that we should identify a tool uh, uh, which is uh, which is direct competitor of JMeter and which can perform better in such scenarios. So what I did is I basically zeroed down on 3 to 4 tools. One of that tool was Grafana K6, other tools like Locust, Gatling. I carried out small POC with these tools and selected Grafana K6 as my go-to tool. So once we selected this tool, what happened is we created different scenarios against that particular API. So this API used to take parameters like customers PI data and used to give information whether that particular customer has HDFC life policy or Exide life policy. So we anticipated that this particular API will take somewhere around 100 requests per second. So we were expecting this particular API to respond in that particular fashion. But when we ran our performance script for the first time, sadly we got 30 requests per second throughput. We gone back to the drawing board and found out what might be causing this performance slowness. So we made fixes at 2 stages. One was at application level and another was at infra level. So at application level, we found out that one of the SQL queries, one of the SQL queries, we were using lots of group by clauses. So we simplified this query and we ran our script again. So that immediately improved our performance to 70 requests per second. And once we are done with that, we found out basically we cannot go beyond this point. So application level fixes are were already in place. So what can be done? So we what we did is we did some optimizations around the infra level. So at infra, we introduce a concept called as ALB. So ALB is nothing but application load balancer. So as everyone is aware, application load balancer will distribute the load when a threshold is reached, and it will spawn a new AWS server in case the threshold is getting met. And one more thing that we did is there is a concept called as pre-warmed ALB. So pre-warmed ALB are basically the ALBs which are in already warmed up state and which can handle basically huge amount of requests per second, and they cannot. So because of that, what will happen is they cannot. So you cannot have slowness issues in your application. So we did that pre-warmed ALB setup as well. And after that is done, we ran our performance script again. And this gave us the result of 130 requests per second. So this is one of the case study that we achieved. So the learnings that we can take out from this is, yeah, you need to have a proper test plan in place. Once that is done, what you need to do is you need to have different scenarios. Let's say your API takes certain parameters like mobile number, customer's date of birth, as well as customer's email ID. So you need to run the query against parameterized data as well. So you need to have the replica data set which is exactly matching to the production or kind of replica of the production. And you can use this data set to run your parameterized performance test. That is one thing. Another thing is basically you need to replicate your production environment setup or configuration. So generally what happens is your staging environment and development environments are of lower capacity or lower configuration uh, when it comes to matching with your production environment. So you need to have separate environments created for performing or carrying out the performance test. So once you have similar configuration, then you will be sure that when actual users will be logging onto your system or carrying out the various steps on your production system, you will be sure that you have carried out all the scenarios on the similar environment. So that is another thing. And another point which is very important is once your performance scripts are run, you need to take help of your development team or the DevOps team in case you don't have access to your APM tools. So APM tools are nothing but application performance management tools like New Relic or AWS console, where you can monitor your CPU utilization, memory utilization. So when your performance scripts are running, you can simultaneously monitor these key metrics and make sure that your performance scripts are not causing too much of spike to memory usage and CPU utilization. So if you consider all these steps, then I think you would be in good place. Thank you.